All right, moving on to hyperbolas. Hyperbolas look a lot like ellipses, but they're a little different. We'll see how. We are on lesson 9.5. We're working with hyperbolas, and our essential question is, can you understand the relationship between the foci, the intercepts, and the asymptotes of a hyperbola? We're going to start learning how to graph these. I'm going to have to grab my calculator real quick. And just like ellipses, they look very similar to ellipses. We need this y to be over here by subtracting. So I have 16x squared minus 9y squared equals 144. And like ellipses, everything needs to be equal to 1. So I'm going to divide here by 144, here by 144, and here by 144. And when I cancel out, 16 goes into 144 9 times, and 9 goes into 144 16 times, and this is equal to 1. So what I have is x squared over 9 minus. So know the difference between an ellipse and a hyperbola. A hyperbola has a minus. Y squared over 16 is equal to 1. To graph this, I'm going to do the exact same thing. The first thing I have to do is look for that center. In this case, it has not moved. We're still at 0, 0. So my center is at 0, 0. And because under the x there's a 9, I'm going to take the square root and go 3 to the right and 3 to the left. And because under the y squared there's a 16, I'm going to take the square root and I'm going to go up 4 for that 16 and down 4 for 16. Now, the difference between this, obviously the first difference is it has that subtraction. The second way I know that you are graphing this by hand and not just using a calculator, and you do need to know how to graph these by hand, is you're going to draw a rectangular shape when graphing this. So there's my rectangle. And then we have to draw what we call the asymptotes. So the asymptotes are going through the corners and through the center. So notice I have two asymptotes that are just linear. And now I'm going to draw my hyperbola with pink. So notice my hyperbola looks partially like a parabola, but notice it's in pink. And there are two of them, and they kind of go along those asymptotes and they touch right at the center. So I have my hyperbola in pink, and notice it is graphed on the x. And the reason it's graphed on the x is because the x came first here. So that's going to change for us. And since all they're doing is asking us to graph these hyperbolas, we're going to look at the next one. The next one, notice, we're going to do the same steps. And I'm going to go ahead and subtract that 9x squared over. And then I'm going to divide everything through by 9 to make it equal to 1. So notice my new equation is going to be y squared over 9 minus x squared over 1 is equal to 1. So this is what I'm going to graph now. Same hyperbola. The center is at 0, 0. So I know the center of this guy is right here. Because under the y it has a 9, on the y I'm going to go up 3 and put a dot, down 3 and put a dot. Because under the x there's a 1, I'm going to put a dot at 1. Remember, when you're taking a test or a quiz, the graph paper will be given to you. From here, I'm going to draw my rectangular shape and my asymptotes, but something's going to be a little different here. So remember, the asymptotes go through the center and the corners. But the difference on this one is because this y squared comes first, my hyperbola is going to be here and and here. So notice it's graphed on the y if the y comes first. So on the ellipses, the movement of the a squared and b squared tell you what to do. Really, it's all going to go the same way. But with the hyperbolas, remember, if the y squared comes first, you're going to graph it on the y. If the x squared comes first, you're going to graph it on the x. So now we're going to learn a little bit about the foci and everything else, okay? So let's go ahead and start. It says find an equation of the hyperbola having a foci of 0, 3, and 0, -3, and a difference of the focal radii equal to 2. Well, that doesn't make much sense to us yet. The first thing I'm going to need to show you is the equation of a foci. So for a hyperbola, the foci is a squared plus b squared is equal to c squared. So with the ellipse, remember it's added for the equation, subtracted for the foci. For the hyperbola, it's subtracted for the equation and added. So let's say that I had to find the foci of this one right here. This one we just did. Let's find the foci. Okay, I know the foci is going to be from the center 0, 0, and in this case it's going to be on the y, because remember the foci are going to be somewhere kind of in between these two little parabolas right here. But I have to use the numbers. So this time I'm just taking the numbers and adding them, because this a was 3, remember 3 squared, and this b was 1. B squared is equal to c squared. So I know that 10 is equal to c squared, where c is equal to plus or minus root 10. Well, remember that's just a little over 3. So if I was to count this, 1, 2, 3, my 10 would probably be right where I had it, maybe a little closer to the hyperbola. And if I was to count negative, I would go 1, 2, -3. And again, I was pretty much on, maybe a little off. But remember to write the foci, we have to write them on the y at 0 plus or minus root 10. So this next question is a little bit backwards, because now they're giving you the equation, well, they want you to find the equation, but they're giving us the foci. So I always graph first, because I like to graph first. And I know the foci are at 0, 3, 1, 2, 3, and a 0, -3, 1, 2, -3. So those are the foci. And remember that this distance was equal to that c squared. You can't see it anymore, but the foci, I'm going to write it darker. The foci is equal to a squared plus b squared equals c squared. So what does it mean that this distance of the focal radii is 2? So this is the part that we're, what does this mean right here? So the distance of the focal radii, we're going to go ahead and set up an equation. 2a is equal to 2, where a is equal to 1. So that's saying that it's going to have a intercept right here and right here at plus or minus 1. Sorry, that should be a 1. So I'm going up 1 here and 1 here. So I know that my hyperbola is going to be a y squared, and I also know that because it goes along with graphing a parabola where it hugs the foci, the focus. Okay, so I'm probably not drawing these right, but that's what they're going to look like. And really, we don't have to draw it. We just have to write the equation. So here's what I know. I know that it's going to be a y squared. I also know that it's going to be equal to 1. Because of this right here, I know that this will be 1 squared, which in this case is just 1. So I'm just going to write that as 1. But now I have to find this number right here using the foci right here. So remember, we know 1 squared plus what is equal to 9, because this distance right here was 3. The 1 we got from here, the 3 we got from here. So I know that b squared is equal to 8, because 1 squared is 1. So my equation I just did is right here. Y squared over 1 minus x squared over 8 is equal to 1. So that would be the whole equation. Y squared over 1 minus x squared over 8 is equal to 1.